Hello and welcome to another tutorial of CHE 101. So for today, we will be discussing entropy of mixing under Physical Principles 1. So for the outline of our discussion today, first, we will be introducing a sample problem. Then we will discuss the theories that we need to solve the problem. So for entropy of mixing, we will need to define heat, sensible heat, entropy as a function of pressure and temperature, entropy of mixing. Then we will thoroughly discuss our solution and finally summarize the discussion. So moving forward, our sample problem, 40 grams of nitrogen gas at 40 degrees Celsius with pressure originally at 1 atm and 20 grams of ammonia at 80 degrees Celsius with pressure originally at 1 atm are mixed, resulting in a total pressure of 1 atm. Assuming gases are ideal, find the entropy of mixing. So, discuss muna natin yung theories that we need. First, yung heat. So, ang heat absorbed ay equal lang siya sa heat release. Meaning, Q abs plus Q release is equal lang sa 0. So, ang nag-iiba lang sa kanila ay yung sign since yung absorb ay positive, then yung release ay negative. So, parang nagka-cancel out sila. Then, sensible heat is siya yung heat na nagre-result in a temperature change but not in a phase transition. So, yun yung keyword. Nagre-result siya ng temperature change, hindi sa phase transition. Phase transition meaning from liquid to vapor or vapor to liquid or liquid to solid. So, ang sensible heat din ay isobaric process siya, meaning nangyayari siya at constant pressure, kaya heat at constant pressure din siya. So, equation niya is this one, moles times molar heat capacity times change in temperature. Then next, entropy as a function of pressure and temperature. Ang entropy is yung measurement lang ng state of disorderliness ng system. So, ang change in entropy as a function of temperature and pressure is yung moles times yung molar heat capacity times yung natural log ng final temp over the initial temp plus yung moles times gas constant, universal gas constant, then multiplied by the natural log ng initial pressure over the final pressure. Then we have entropy of mixing. It is just the sum ng entropy changes ng all gases mix. So, final partial pressures ng gases, assuming isothermal mixing, is yung partial pressure ng gas equal lang siya sa molar fraction ng gas times yung total pressure. So, ito yun. Moles ng A all over total moles times times total pressure. So, going back to the problem, ilist natin lahat ng given. Ito. This one. Then, we will get this. So, mass ng nitrogen gas is 40 grams. Temperature niya initially is 40 degrees Celsius or 313.15 Kelvin. Then, initial partial pressure is 1 atm. Then, for the ammonia, 20 grams, 80 degrees Celsius, 353.15 Kelvin, then 1 atm. So, tapos, ang total pressure natin ay 1 atm. Ang required sa atin ay entropy of mixing. So, ang equation that we need is this one. Entropy of mixing is just equal to the entropy ng nitrogen gas plus yung sa ammonia. Then, since alam natin na may temperature and pressure changes, we will define the entropy of the individual gases in terms of temperature and pressure. So, as a function of temperature and pressure, ang equation niya are these two. Then, we can see na yung mga naka-red is yun yung wala sa given. Need pa natin isolve. Then, yung green is meron sa given. So, meron na tayong initial temperature ng individual gases, then initial pressures nila. But we don't have the final pressures, the moles, and the molar heat capacities. So, ang solution natin is solving for the unknowns muna. First, yung moles, which is just equal to the mass over the molar mass. So, solving for those, we get 1.43 moles nitrogen gas and 1.18 moles ammonia. Then, the total moles is 2.61 moles. Next, getting the molar heat capacities, meron tayong equation na to, Cp over R is equal to A plus Bt plus Ct squared plus D over T squared. Plus yung AB, where A, B, C and D are the constants. And for this, we will use R equal to 8.314 joules per mole Kelvin para in terms of joules ang ating sagot, and consistent din yung moles and Kelvin natin. So, getting the values from the table, ito yun, tabulating them. Then, solving for the molar heat capacities at these temperatures, we will get 29.15 joules per mole Kelvin, 37.37 joules per mole Kelvin for ammonia. These are just substituting the values here. Then, this temperature, then here's the temperature. Then, the R is 8.314 joules per mole Kelvin. Then, next, solving for the final temperature, yung ito rin, this one, pwede nating gamitin yung heat absorbed plus heat release since alam nga natin na may nangyaring thermal equilibrium. So, meron tayong heat ng nitrogen gas plus heat ng ammonia equals to 0. Then, ang nangyari ay sensible heat since may change in temperature tayo, yun yung keyword, since nag-change ng temp, mayroong sensible heat. Then, this is the equation for the sensible heat. So, ang wala dyan is yung final temperature. Substituting them here, ito, then this one here. From this equation, we get this. Then, meron naman na tayong moles and molar heat capacities. And meron na ring initial temperatures. So, ito na lang ang matitirang wala. Then, directly inputting the values sa calculator natin, then letting final temperature be X, pwede natin i-shift, solve, thus enter, then we will get this final temperature, which is 60.56 degrees Celsius or 333.721 Kelvin. Then, finally, ang last na unknown natin, which is yung final partial pressures, which is just the molar fraction times the total pressure, and nakuha na rin natin to kanina, then 1 atm from the given. We will get 0.5479 atm for nitrogen gas and 0.4521 atm for the ammonia. So finally, meron na tayong lahat ng unknowns. We can get the entropy of the nitrogen gas and the ammonia, which is 9.80 joules per Kelvin and 5.29 joules per Kelvin respectively. Then, substituting sa entropy of mixing natin, which is just adding this together, we will get 15.09 joules per Kelvin. So, to better guide you in solving this problem, here's the complete solution. And you can pause the video here and take a screenshot. So, okay. So, to summarize our discussion, first we solved for the moles of the gases. Then we calculated for the molar heat capacities at the given temperatures. Then we determined the final temperature through the heat equations, yung heat absorbed and released and the sensible heat. Then we solved for the individual entropy of the gases as a function of temperature and pressure. And we got the entropy of mixing by getting the sum of the entropies. So, ang tip here is mag-base tayo sa given. Since nakita natin na may temperature and pressure changes, then entropy ang hinahanap. Then, clue yun na ang entropy natin is as a function of temperature and pressure. Then, yun din, since may temperature change tayo, clue rin siya na we need the sensible heat to solve for the final temperature. And that's all for the discussion. If you have any questions, you can send an email through the chen.acads Gmail or send a message through our Facebook account, chen.acads Hub. So that's all, and thank you for listening to today's video.